Okay, so now I got things on my breadboard. What I've done is I've just connected a couple of potentiometers to the inputs on the op amp, and then we have a little bit of metal, just a teeny tiny little metal jumper in there. And the reason I've done that is now I'll be able to adjust the inverting and non-inverting inputs on the op amp and see actually what happens to it as I adjust the input voltages. So, first thing I want to do is figure out what I'm doing with my potentiometers. So I'll take these off of there right now and turn on the power supply. And I already know that I'm going to be getting, ta-da, my regulated voltage there. So what am I getting here? So off of this potentiometer right now, I'm getting the full 12 volts, and spin it around, take it all the way down to nothing. Okay, and on this one here, yeah, I'm getting the full 12 volts, and spin that around. So yeah, that nicely, gives me a couple of controls for the inputs on my op amp. So right now they're both set at 0, and let's see here. The blue one is going to be my inverting input, and then the yellow one is my non-inverting input. Okay. And I don't have any feedback on the op amp right now, so essentially it's just going to be a comparator. So, get my probes untangled. There we go. Let's go ahead and see what's happening with the output on the op amp. I have ground over here, output here, and yeah, so right now my op amp is high, so let's go ahead and turn up my non-inverting input a little. Hey, look at that, the op amp just went really low. Okay, and that's because, right there, that's high, and that's low. So yeah, I mean, it's not, much of a difference at all. And what do we got here? We have just 2 volts on the potentiometer and ground there. So yeah, just took it to ground. So let's go ahead and turn up this one just a little bit. That'll take it back to high as soon as this gets to be more than that little 2 volts. There we go. And we can actually kind of see that in the position of the potentiometers. If I can get my probe in there again. So yeah, the inverting input is 1.97 volts. The non-inverting input is 2.61. So yeah. And little LED needs to get out of the way. There we go, yeah. So just under 2. And just over 2. So if I take this down to the just under 2. Yeah, there we go. Now, okay, so my non-inverting input is 1.8. My inverting input is 1.9. It should be railed low. And yeah, it looks like I am. Let's turn this, the inverting input down a little. Yeah, railed low. Go up. There we go. So that is pretty good. What that means is I need to take that output and run it for, this aspect of my circuit. Let's say that the non-inverting input is the input coming off my thermistor. The inverting input is the input coming off my hot, okay, through a potentiometer from my set point. So this would be my set point, and then this would be the reading off of the thermistor. So the set point there, when the non-inverting input is higher than when the inverting input is higher than the non-inverting input, this op-amp will rail down to 2 volts, which is as low as it can go. Well, 1.9. Let's see here. That's a 0. And that's a 0. So, okay, they're both the same, so I gotta pull that up a little. I'm dialing up the right one. Yeah, here we go. So yeah, pull my non-inverting input up off of the ground a little. Yeah, there we go. Or, I'm sorry, pull my inverting input off the ground. Okay, there we go. So, yeah, that right there with the inverting input, that should be when the temperature is high. Yeah. So yeah, the next thing to do is to get rid of that 1.27 volts off the output of the op-amp. So I'm going to see what I can do about that.